30th year working in IT with 4 years specializing in AWS cloud workloads. So, what can I do for you?
For 13 months, we have collected and utilized the most potent of enterprise software for our Java 8 applications running on JBoss. You are here to finalize and optimize the function of our new flagship application and unleash a fully operational stocksforcats.com upon the universe.
Great. What do you have it deployed on now?
It's currently on my laptop. Only on my laptop.
Okay. Is there any installation script to move it off your laptop?
No.
All right. We can work through that. How are you testing the app?
I personally validate every version.
Okay. So what DB are you using?
SQLite.
So it writes permanent data directly to the disk.
Yes.
Have you tried running 2 copies of it for redundancy?
This application cannot fail.
How's the startup time?
Well under 10 minutes.
How do you stop activity to do a database backup?
Oh, it must never stop.
I should also warn you that right now, it has to run as root.
This software must treat security with the highest possible
We
regard.
tried using the latest version of Java, but it broke stuff, so I might go back to 6.
We need to deliver in 4 weeks.
I might need some help getting build time down under 2 hours.
345,000 users at
I
launch.
missed my mother's funeral.
Where did you go to school?
My wife left me. My dog left me. My cat left me. I haven't slept.
Hey, did you order these?
Thanks. This video is a short, non-technical primer on what you should do to get your new web app from an idea into production. If you only want to stick around for 30 seconds, the basics are going to be that you need to decide on an architecture to drive you until your application has a steady revenue stream, not something that'll take you to a bazillion users. Figure out how to build everything where security issues aren't going to make you either insolvent or incarcerated. Build tooling for your developers to easily write, validate, and iterate on the app and on the architecture. And finally, get visibility into the system. When it comes to web apps, we use architecture to describe how the building blocks of hardware, services, and software fit together to deliver your application to the world. Much like traditional architecture, there are many ways to make your application available to users, each with its own target size, maintenance needs, and specialty features for the intended use. And this cannot be stressed enough. Architecture is money. It is going to be a dominating factor to determine your IT operational costs as you grow. Following 4 architectures show you different ways to perform an extremely common task, in this case hosting a WordPress site. And they're all valid solutions if you're using them within their design specification. If you do not, the best case scenario is that they fall over and stop serving pages. At worst, they hemorrhage money wildly outside of the scope of what you're using it for. It's extremely easy when starting a project to jump into making the code without considering the growth of your business and the maintenance needs. This approach fails in many ways, but the most common 2 ways are: you use technologies that are designed for small, easy to maintain deployments where you absolutely require much more scalability or reliability. Or, you shoot for enterprise-grade out the door and incur crippling costs to run your site before you have the volume to justify it. Either one can have dire issues that either prevent you from growing at the rate you need, or worse, prevent you from getting a working version out to the public. How you account for all this is to set realistic expectations of how you intend to grow and what your company needs to survive. Even this varies wildly from company to company. Venture-backed companies will have very different math than someone working a second job to build out their side hustle. The important part is to make the first version viable on your budget and get you to a place where you can grow it. My rule of thumb is that your first version needs to handle the first 3 orders of magnitude of your growth for anything with pay-to-use business model, and 4 or maybe 5 for busy freemium sites. If you're setting up a minimal site to see if your product is viable, DigitalOcean, Heroku, Amazon Lightsail, and many other small service-focused providers exist and can handle running your application and keeping it backed up well enough for you to get an idea if it's going to work. Now, Amazon likes to say security is job zero, and that's because we always forget about it. This topic is huge, and I can't get too into it because everyone's situation is very different, but let's go over the basics. Dan's rule of DevOps number 9. Security is the concrete and justifiable steps you take to protect the loss and compromise of your data and assets and limit your liability in the event of a breach. It is not a fairy wish you make out into the ether to keep the hackers out. Remember that security is a process, not a product. And realistically, what you're trying to protect is Personal data causing a legal liability. Your business assets. Your site going down, causing a bad reputation or loss of revenue. That first one I mentioned is the big issue. If Hacker Dan breaks your website and redirects all your traffic to the Rick Astley's Never Gonna Give You Up video, you have been shamed, and you should feel bad about it. However, no one from the FBI will knock on your door, and you aren't going to be asked to pay out millions in fines. Which you will, if Hacker Dan gets himself some credit card numbers instead. There are various frameworks for dealing with how to handle this, but the too long didn't read version is this. Write down all the bad things that can happen if someone gets a hold of the stuff you don't make publicly available. This includes source code, back-end reports, metrics you collect on operations, as well as legally actionable personal identifiable information. Figure out how someone could get each one of those. Assign a number between 1 to 5 on how often someone will try to get that, and a number from 1 to 4 on how severe the impact will be. Put it in a cybersecurity matrix like this one. Assign a dollar value impact for each incident. Have very solid mitigation strategies for anything where that number will cause your boss, wife, or the Justice Department to give you a bad day. Realistically, offload any financial operations or PII that would trigger legal consequences to services designed to secure them. Follow their rules. For secure services you can't offload, move them to another internal service that is responsible for updating and querying them. This comes down to putting sensitive info behind a second system with a second database and revalidates the access to it on every access. Practically, this means somebody would have to break through 2 different systems to get to your secure data. This service should set off literal alarms if somebody starts blindly poking around. Ensure any credentials that would be used to hack your site cannot be used for anything else. Code check-ins, back-end operations, logging onto your Facebook page, whatever. If at any time it becomes impossible to secure things enough to cover the price of the consequences, you unfortunately do not have a viable business. You'll need to rethink things or have your tickets ready for that non-extradition country. Next, let's talk about getting your code into the public eye. There's a very good chance that the nascent stage of your app's life will live in a very small number of computers, built and run locally. This is fine while working for a proof of concept, but once a glimmer of putting it in front of more than a few dev staff exists, you'll have to set up a testing environment that matches the final architecture closely enough that you can trust your testing. Today, most people use continuous integration where the code is deemed ready to show to others, is submitted, merged into the application, automatically tested, and made available for others to use. This is usually followed by continuous deployment systems where the new code is deployed to a hosting environment that closely matches what it will eventually be released on. With a properly set up system, you can go from showing a new version once a week to 5 times or more per day. You can also set up individual environments to test specific features or additions to the code, allowing your devs independent access for testing their own stuff without having to give each one a potentially expensive set of servers to do it. All-in-one solutions that handle the CI/CD as well as incident tracking and documentation include GitHub, GitLab, Azure DevOps, and Bitbucket. Alright, finally, you want to ensure that you can get information on how your application is performing so you can investigate issues and get alerted to when it isn't running as expected. I would absolutely recommend just getting one of the commercial products to handle this. Datadog or New Relic will take care of everything you need, and they are not particularly expensive in the small scale. Large scale is... yeah. If you want to roll your own, Prometheus, Grafana, and Loki can handle metrics, logs, and the reporting on all of it. From these, you should be able to set up alerts for critical metrics that tell you when things will break, or have broken. If you don't know what these things are, use some basic load tests to stress your application until it breaks, and then go back to the graphs to see what started causing the issues. Your application should also report and emit events or log messages as noteworthy things happen. Signups, deletes, revenue changes, etc. This will be very handy when you set up a dashboard or need to find out what correlates to what. Hope you found that useful. As always, I'm Dan, your humble cloud architect. If you think I could do better or want to talk about what I presented here, please feel free to start a discussion in the comments. If you think I can help you with your app, please visit my website. Check out this next video for some tips for devs if you think that's helpful. And as always, thank you and goodbye.